So Chapter 8 is all about similarity, and the first section is basically a review section from way back at the beginning of the school year when we were doing types of transformations. We touched briefly on something called dilations, and that's basically this first section is just a review of that with a little bit of an extension into what we're going to do in Chapter 8 with similarity. So let's go after a couple of problems here, and the first problem we're going to go after is this very first problem. So this very first problem here, it basically is talking about taking a segment with endpoints -5, 2, -2, so right here, and B is 6, -4, which is right here. So this is the segment we're talking about, and what we're going to do is we're going to dilate that segment. And the center of dilation is going to be at 3, 1. So there's the center of dilation. Now, and what we're going to do is we're going to dilate this by a scale factor, or a scale factor of k, equaling 1.5. Now, if you remember, looking way back at the beginning of the school year, when the k factor is bigger than 1, the resulting transformation is going to be that the figure is going to get bigger. When it's less than 1, it's going to get smaller. And when it's negative, it's going to go in the other direction. So we'll talk about that a little bit as we approach this problem. There's two ways to approach this problem. The first one is, what I could do is I could take P and I can move this to the left 3 and down 1 so that the center of dilation actually ends up being at the origin. And basically I'm going to take all these and move it to the left 3 and down 1, left 3 and down 1, like this. Okay, and then from there I'm just going to go ahead and multiply everything by the scale factor 1.5. And then don't forget that when you get to the end, you have to move everything back up 1 and to the right 3. I'm going to go ahead and try this problem without doing that though. I'm just going to move it using the scale factor that's given there. And basically, what I have to know here is that, okay, from P to A, what is my difference here? It's going to be from P going to A, it's going to be -8 in the x direction and -3 in the y direction. Okay, so we're sort of putting that in using vector notation there. And so if I multiply both of these by 1.5, I'm going to end up with moving this -12 and -4.5. So I multiplied -8 by 1.5 and -3 by 1.5 and got this. So from the center of dilation, I'm just going to go -12 in the x direction, and then I'm going to go -4.5 in the 4.5 in the y direction. So I end up right there. And so the result is going to be, I'm going to end up at A prime equaling -9, -3.5. Okay, so that's this point right there. And I can do the exact same thing for my B coordinate. And when I do that exact same thing, well, let's go ahead and do this quickly. P to B is going to be -3 in the x direction, -5 in the y direction. Multiply that by 1.5. So P to B prime is going to be 4.5 in the x direction and -7.5 in the y direction. Again, I'm just multiplying the original x and y values by 1.5. So P b prime is going to end up being, if I go 4.5 in the x direction, negative 7.5 in the y direction, it's going to be 7.5, comma, negative 6.5. And those will be my new coordinates for a prime and b prime. Okay, I'm going to move on to the back side, and let's go ahead and try one more problem. Okay, we're on the back side here. We're talking about this triangle right here being a dilation of the original triangle, which is the orange one right here. Okay, and we have some values here. This is 7, AB is 14, CE is 3, and BD as an entire length is 18. Okay, we're supposed to find the scale factor that's used to map this smaller one to the bigger triangle there. And so let's just take a look at an individual point. And if you look at this, here's the center of dilation, and the original amount was going in this direction, 3. Now, we didn't really talk about it on the front side, but basically when it goes in the negative direction, when your scale factor is negative, the resulting point will actually be in the opposite direction. So this is going to end up giving you a negative scale factor. And you can see that this scale factor here is going to be bigger than 1 because this amount 7 here, is bigger than the original amount, which is 3. And so keeping in mind that what we usually do is we take the 3, which is the original amount, multiply that by the scale factor, and you will get the new amount, which is 7. So your scale factor in this case would just be, solving for k, 7/3. And we know, because it's in the opposite direction, that this is going to be a negative. That means that the point went in the opposite direction. So we have a negative scale factor. Now we're supposed to find, on the next part here, we're supposed to find the length of DE, which is this one right here. Let's call it y. And so using the same thing we just did, it's going to be whatever the value of y is, which we're looking for, times our scale factor, which is negative, well, let's just use positive 7/3, because we know it's going to be in the opposite direction already. We don't need to use the negative. So negative 7/3 is going to give you, over here, 14. And so if I solve for y here, multiply both sides by 3/7, y is going to be equal to 14 times 3/7, or it's going to be equal to 6. So y is going to be equal to 6. So that would be the way to do this using scale factor. So this is what's called this method 1. The second method is really what where we're headed with this. So I'm going to kind of split the screen here, or split this problem here, and call this method 2. And this basically hints at the similarity type of problems that we're going to be doing and using proportions. So just to kind of give you a little foreshadowing here, what I can do is I can use this. So 3 is to 7. So 3 from the smaller triangle is to 7 of the bigger triangle, as y from the smaller triangle is to 14 from the bigger triangle, which is the corresponding side over there. And again, if I solve for y here, I'm going to get y equals, and I solve this thing, I get y equals 6. which is what we were looking for. Okay, so let's try that method for this next problem here for finding the length of DC. So DC, let's call this X, and we know that the entire length is 18, so that means that this portion here is going to be 18 minus X. That's what this portion right here is going to be. So if this is X, and the entire thing is 18, and if I subtract X, I'm going to get that portion right there for BC. So I'm going to set up the same proportion. So it's going to be 3 from the smaller triangle is to 7 from the bigger triangle, as X is from the smaller triangle is to 18 minus X is from the bigger triangle. Then I'm going to cross multiply, okay, which we'll talk about quite a bit in the next section here. And so 7X is going to be equal to 54 minus 3X, or X, 10X, is going to be equal to 54, or X is going to be equal to 5.4. Okay, I think that's it for this problem here. I'm going to let you go ahead and, I know that this was kind of crazy in that I introduced some new methods here and here, but I'm going to go ahead and let you try some problems on your own. All right, good luck.